composite functions, I posted this worksheet for you with composite functions. It explains the definition of composite functions, that they are one big function that is made up of smaller ones. We talked in class about when we have systems of equations. So we had x equals 2 and then y equals x plus 3. How we could solve our system of equation by substitution. We could take what we knew from one of the equations and we could plug it in to the second equation. So when we have a system of equations, we could solve either through substitution or we could then add and subtract them together. A composite function is the substitution form of systems of equations. So remember, a function is simply a way that we are naming an equation. It's not anything different. It's simply the name of an equation. And so now we are combining. Composite is another word for combine. We are combining two different equations through substitution. Okay, so when we solve, for example, in this one, this is said f of g of x. We didn't talk about it in class, but when they put the little O, that is the word of. It's a short version of the word of. So this is read f of g of x. So we're talking about the same variable for both equations. The g is the first one that you solve. F is the second one that you solve. So we're going to start on the inside and move to the outside for it. So we would find the answer for g of x, and then we would plug that answer into f. If it was written a different way, g of f of x or g of f of x, we would find the f of x first, find that answer, and then plug that into g of x. Those are often different answers because you're going in different orders. So even if you think about maybe sports, you do one thing first. So you take 3 steps and then you shoot. That's going to come out with a different outcome than if you shoot and then take 3 steps afterwards. So sometimes they are the same answer, and that is a specific type of system of equations. That's called an inverse equation. So when we were talking about those transformations, when we have an inverse there, but otherwise it will usually be a different answer. So this is an example where we have our 2 different equations. So this may be system of equation number 1. We would have written it y equals x squared plus 1. And this one you would have seen y equals 2x plus 5. Okay. But because they're different ones, we're naming this one G, this one F, and we're deciding which one we have to plug into. So when we want G of F of X, the one that is labeled F would then be plugged into the G. In this case, they give us X equals 2. So we're going to solve our F value right here. So we're going to plug the number 2 in. 2 times 2 is 4. 4 plus 5 is 9. So now I have an answer of 9. I'm going to take my 9 answer and I'm going to go over here and plug it into my G. So now I have 9 squared, which is 81, plus 1 gives me 82. That's what they worked right here. When we work the opposite direction, f of g of x, or also written with the parentheses, we're going to start with the G. So we would start, this would be the first equation, g of x here. So we would take our 2, we would plug our 2 in right here. So we'd have 2 squared is 4 plus 1 is 5. So now we have a 5, and then we're going to plug 5 into here. 2 times 5 is 10. 10 plus 5 is 15. That's what they show right here. So we're choosing one, plugging into the other, or we can go the opposite direction, choose the first one, plug it in. Depends on which order they say. We always start with the function that is closest to the x or the function that is on the inside. And as you can see, we got 2 different answers on that one. So when we solve them, in this first case, we went ahead and we already had a number that they gave us for x, and we plugged that in. If we don't have a number, or if we're going to be solving for lots of numbers, doing the 2 different steps can be time consuming. So just as when we had systems of equations, so we did y equals x or y equals x, say y equals x plus 1, y equals x squared. When we take one and we plug it into the other, we could just rewrite this as y equals x squared plus 1. We have substituted, x squared equals x plus 1. We have substituted x squared into the y in this equation. In the same way, we can substitute in the first place. So they gave us the same 2 that we were working with on the other side. But now, if we are doing f of g of x, we are going to take our g of x, and everywhere that we see an x in the next one, we're going to plug it in. So now we have 2, and then where we saw an x right here, we're going to put x squared plus 1 plus 5. So if we rewrote this, this would be 2x plus 5. Well, that matches our f of x. We have just replaced our x value with our x squared plus 1. So now we have a new equation that we can go ahead and simplify, and we can work that through for every x value. This is when we've gone ahead and substituted and combined them. Now, on this little bottom part, it talks about inverses. It says an inverse of a function is where you switch your x and y, and then you're solving for y again. Remember, a function is a y equals equation. So we need to have it solved for y for it to be a function. So in this case, if we have that they gave us this function, y equals 3x squared plus 4, so we could rewrite this as f of x equals 3x squared plus 4. Remember, it's just another way to name it. To find our inverse, we are going to switch our x and y. You can see it right here. Now, x equals 3y squared plus 4. Now, the goal is to solve for y. So we would solve for y the same way we've always solved an equation. I want y by itself. I'm going to get rid of the 4 first. So we move the 4 over. We have x minus 4 equals 3y squared. We get rid of the 3 second by dividing both sides by 3. Now I have a square root. So I'm going to take the square root of one side and take the square root of the other side. So y is the square root of x minus 4 over 3. So now I know that y equals 3x squared plus 4 and the square root of x minus 4 over 3 are inverse functions. What they will do is when you plug in the same number, or when you go back and forth, g of f of x or that f of g of x, depending upon which one you go, 1 then 2 or 2 then 1, you will get the exact same answer both directions. So on this front side, we did not get the same answer. These equations are not inverses of one another. On the back side, if we were to solve these two for any number, no matter what number of x we put in, when we solve this, we would always get the exact same value.